A dynamic adaptive building facade has the ability to repeatedly change some of its features and functions in a reversible manner, responsive to variable environmental conditions. Such dynamic relationship between a building facade and its surrounding environment may allow for a better overall performance of a building. A dynamic change in a building facade, such as extending or retracting a shading device, requires actuation of elements of a dynamic adaptive building facade. How such actuation is provided is an important factor from an energy-saving point of view. However, utilizing large numbers of electric motors, pneumatic and hydraulic actuators in a building facade may not be energy efficient and require a large amount of energy to operate and significantly increase the maintenance and repair costs of the building. There is therefore a need for developing new actuation mechanisms that are energy efficient with less moving parts.
The main idea was inspired by domino effect, which can easily be visualized by placing a row of dominoes upright, each separated by a small distance. Upon pushing the first domino, the next domino in line will be knocked over and so on. The main question is, if the dominoes are replaced with permanent magnets, does the system work again? To answer the question, in the first stage, 3 similar magnets was positioned beside each other, with the same distances between them. Then by theoretical studies, it was concluded that it's impossible to rotate 2 other magnets just by rotating the first one due to air and other parts of system friction forces. To tackle the problem, it's necessary to produce a bigger magnetic field between 2 first magnets, which can overcome the next magnetic field. In other words, the first magnetic field must be the most powerful one. Then the other magnetic fields should become weaker and weaker in turn. Due to the Gilbert model, if magnets with same characteristics is positioned beside each other while just the distances vary, the only parameter which is not similar for magnets is x, that represents the distance between each 2 magnets. Therefore, the force between magnets just depends on the distance in this situation. If the first distance is lower than the second distance, then F1 is bigger than F2, and this relationship can be written for other distances and fields. Consequently, when F1 is bigger than F2, next magnet is forced to rotate and cannot counteract the more powerful force. The wave of rotation in system continues until the force between magnets become negligible.
In this prototype, 19 neodymium magnets with highest grade, which all are the same size, have been used. As it is obvious in the slow motion, by rotating the main magnet, the other magnets have to rotate their poles, which produces a wave of change in the system. In other words, all the magnets have to comply with the poles pattern of stronger fields. It should be considered that it is possible to add new magnets to system until the distance between them does not go beyond the normal limit. In this system, the output of the motors is rotational motion, which according to the needs may be transformed to horizontal, vertical, and etc. The transformation can be carried out by different types of systems such as sprocket, gearbox, rail, and etc. The publication of idea, which is patented by United States Patent and Trademark Office, may be accessed through the USPTO's publicly available databases. Thank you for your time and consideration.